What's up, grade 12s? It is your time for life sciences. I am Luni, and with me today is a very strange Aslam. Aslam, how are you?
Looney, I'm fine. What's happening, Looney? Talk to me, talk to me.
Oh, I'm great, man. So, what's up with the
What's up with
thermometer in your
the thing
mouth?
in my mouth?
Yes,
Just give me a reading there, Looney.
36.5.
36,5 degrees Celsius. That's my temperature at this moment.
All
You
right.
take it from there.
Okay, guys, you saw that little intro there. Aslam was a little hot, 36.5. Is 36.5 normal?
Normal, normal.
Oh, no, he's normal. So he's healthy, he's good.
I'm never
He's good
normal,
to
but
go.
that's a different story.
So guys, anyway, so we're dealing with temperature and stuff. How do you pronounce that?
Regulation.
Thermoregulation, yes, guys. So it's all about the heat in your body. Anyways, contact us on Facebook. Our page is facebook.com/learnextra. Our page on Twitter is @learnextra. You guys can download the show notes, the videos, the schedules. If you want to know how to order a DVD or buy books and all of that information, past papers and all of that, guys, you can go on to learnextra.co.za/live. We've got a lot of stuff going on today's show. I've got lots of information to give you guys. So make sure you do not leave your seats. I don't want you taking breaks, bathroom breaks, drink breaks, nothing. You can't leave. You must stay glued to your screen and watch us the whole hour, guys. Okay. So Aslam.
Thanks, Looney. Thanks for that intro. Well done there. Guys, we are looking at thermoregulation, and we just have taken my body temperature was 36,5 degrees just now. We're going to go back to that a little later. Before we do all of that, let's look at what we're going to do today. Very clearly, we started by telling you that we're going to look at the need to regulate the body temperature in humans. Why do humans and other endothermic animals need to regulate their body temperature, firstly? Secondly, so we're looking at the need. Secondly, we want to examine the structure and functions of the different parts of the skin. Then we want to look at the role of each of the following in temperature regulation. Remember, this section is dealing mainly with the skin in thermoregulation. We're not going into the skin as you would have done in the past, in the old syllabus. When we're saying old, we mean not the NCS, but before that, the NATED, where we went into detailed structure of the skin and functions of each part. And then here we are looking at mainly the role of the skin in temperature regulation. So that's what we're looking at. And for the syllabus, guys, you've got to be very clear on this. The syllabus or the curriculum is dictating the following: sweating, vasodilation, and vasoconstriction. We will explain those words a bit later. But you'll notice that your textbooks may even talk about the contraction of the erector muscles and the standing of the hair and the lying down of the hair, etc. That is not in the syllabus. Although it's interesting to note that, but when you are answering a question on temperature control in the skin, you stick your answer to these. Restrict your answer to these things first. All right? You can mention the other things later. Then we want to know, again, when we talk about structure, how are the parts of the skin adapted to thermoregulations? Further, we want to compare the definitions of hypothermia and hyperthermia. And we want to also finally consider the preventative measures for hypothermia and hyperthermia. And we want to take it one step further. We also want to know what you should do if you find somebody that is suffering from one of these two conditions, hypothermia and hyperthermia. These are the things that we want to look at. So let's kick off straight with the first question. And again, because we don't have to teach this, because you are grade 12 learners, you've been through some of these things before already, so you should be au fait with what we are talking about. And the first question asks you, why do we need to maintain a constant body temperature? Remember, that was our first bullet, the need to maintain a constant body temperature. Now, the clue, the hint here is you need to go back to grade 10 to find out more about what we are talking about. So you've done it in grade 10 already. And yes, you're scratching. I see you scratching your head. Remember, it depends where your brains are. That's where you're going to be scratching. All right? So if you are scratching, look at where you're scratching right now, and then maybe you get the answer to where your brains are today. Don't take that seriously, eh? Okay, so if you found something, you'll know that we are talking about enzymes, and This is why we need this constant temperature, because enzymes usually work best at an optimum temperature, of 37 degrees, between 36 and 37 degrees. That's the optimum temperature for enzymes. You learned this in grade 10. You also learned that high temperatures would denature the enzyme. That means it would change the shape of the enzyme. And if it changes the shape of the enzyme would not be able to work again. Consider the following. If you have a key, and if you use a blowtorch, you know, the welders use a blowtorch, and you heat the key, what's going to happen? The key, the metal will melt, the shape of the key changes. When you put that key in the lock, the door, it would not open the door. So this is what we're talking about here. The shape of the enzyme changes, and therefore that enzyme cannot catalyze the reactions it used to before. And this is irreversible. Once the shape has denatured, once the shape of the enzyme has changed, you can't. Consider again another thing. Remember, the egg white is albumin. Albumin is a protein. So in the egg white, although we call it the egg white, it's actually transparent in the egg itself. However, when we boil the egg, Luni, what happens to the egg white? It becomes
white.
It becomes really white. Now it's actually white. Can we reverse this, Luni? Can we make it back to transparent?
No.
No. What have we done? We have denatured the protein. So we have changed the shape, the structure of the protein, which is irreversible. You can't go back to normal. However, if you take the same egg, not that one, obviously, if you take an egg and you leave it in a fridge and the temperature comes down, the fridge, you know, depending how you set in the fridge, the temperature may be right down. When you take the egg out, nothing has changed in the protein itself. You have just inactivated that protein temporarily. So in low temperatures, they can regain what they're supposed to do, but when you boil them or when you heat them up, there's a problem. So this is why, if we allow our body temperature to go too high, the enzymes will denature. And remember, enzymes control every single chemical activity in the body. When we spoke about protein synthesis, transcription, we said enzymes control transcription. When we spoke about translation, we said enzymes control translation. When we spoke about DNA replication, we said enzymes control DNA replication. When you spoke of respiration, nutrition, digestion, etc. in grade 11, grade 10, you said enzymes control those reactions. So imagine if the enzymes get denatured, what could happen? So that is the reason why we have to have that situation there. Now the next question asks you, which part of the brain controls body temperature? Now you don't have to scratch so hard, because this we did a couple of weeks ago. We looked at the brain, we looked at 5 areas in the brain for which we needed to know functions. One of those parts of the brain that we studied controls body temperature, and that is the hypothalamus. Hypothalamus, remember, controls body temperature. It also controls osmoregulation. It also is the area where emotions, hunger, thirst, etc. are also controlled. Sleep, appetite, all of those things are controlled by the hypothalamus. Apart from the fact, last week we spoke about the hypothalamus and its influence on the pituitary gland. It secretes certain hormones that control the hormones of the pituitary gland as well, although that is not prescribed in your syllabus, but that is also what the hypothalamus does. So we're linking, and again, what I want you to see, guys, here is that when we learn the brain, now we're learning temperature control. They are not different things. These things are happening all the time in the body. The brain, indeed, is involved in temperature control. So you can't see the brain as a topic on its own and temperature control as another topic. You've got to bring these topics together, because when we've set questions, we can ask you from different aspects within the same paper, obviously. In paper 2, we're going to ask you paper 2 items. In paper 1 items. But even if you take evolution, when we did revision on Saturday, you see we brought in genetics, we brought in meiosis, we brought in DNA, etc., into our story on evolution. So these things are all interconnected. Good. We move on. And that brings us to the diagram of the skin. Again, remember, you do not learn structure without functions, and you do not learn structure and function without bringing the two together and talking about suitability, which we will develop as we go along today. Let's look at this diagram. First of all, there are two main layers to the skin, and that is the epidermis and the dermis. The upper layer is called the epidermis, and the epidermis is made up of the conified layer and the malpighian layer. Conified layer, some textbooks may call it the horny layer. All right? This is made up of dead cells that have arisen from the lower layers. These cells are constantly being shed. As we're speaking, skin cells are being lost, and they are being replaced by skin cells from the malpighian layer at the bottom. There is mitosis is taking place, and by mitosis, remember, mitosis, exact duplication. The cells are replicated. Whatever the cells were, they have the same structure and functions, and therefore they can replace the cells all the time. And below that is the dermis. And in the dermis, we find a variety of structures, as you can see there. We have a variety of nerve endings, which will form receptors. For these receptors, by the way, are for heat, cold, pain, pressure, touch. 5 of these different things. Touch, pressure, pain, heat, cold. Different receptors for each of these functions. So we have different nerve endings there. And obviously the skin would be richly supplied with blood capillaries, as you can see there. A lot of capillaries. We also have the hair follicle there coming out. There's the hair. As you can see outside, the hair and the follicle, the hair shaft here. Linked to the hair shaft is the sebaceous gland, which secretes an oily substance which moistens the skin. Okay? If these sebaceous gland areas here, this area gets blocked, there where the hair is coming out. If the area gets blocked, then obviously this oil is not going to ooze out nicely, and this could lead, this is one of the reasons, and please, we're not going to entertain all of your questions on how do we get acne, how do we get pimples, etc. Our topic is thermoregulation. We'll leave that for another day. Okay, so that's one of the reasons you get pimples or acne there, if that gets blocked. So the kind of soap you use, the fact that you must wash your skin regularly, etc., clean it properly all the time, those are the reasons, because if it allows us to block, you can have problems because of that. Okay, with that, we also have the hair erector muscles, which will control the position of the hair. You'll notice sometimes when you're out in the cold, your hair stands, because that erector muscle contracts. And at other times, your hair lies flat because the erector muscle is relaxed at that time. Okay, so the hair follicle. Then we have the sweat glands. And the sweat glands lead to a sweat duct, which opens up onto the skin as a sweat pore. That means the sweat gland secretes sweat. It goes up there and onto the skin. And we're going to be talking about that later, so we won't go into too much detail there. At the bottom, we have lots of adipose tissue. And adipose tissue serves to insulate our body as well. So it is also a form of heat insulation. And the hair can be. But recent studies are saying that the hair in humans does not play such a significant role, because most of us do not have so much hair on our bodies. But in other animals where they have thick fur, etc., then obviously the fur and the hair plays a significant role in temperature control. But more scientists are saying now in our body it's not playing such a significant role. Therefore, it has been downplayed in our curriculum as well. Although it is there, we can talk about it, but remember, for marks, when they talk about hot and cold, you must talk about sweating, you must talk about the sweat glands, you must talk about vasodilation and vasoconstriction. Keep your answer to that, and you can elaborate further on the hair, but the marks are given for those things there. Have I left anything else out? No. These are the more important parts of the skin and their functions. So we need to know this diagram, obviously, to understand what follows hereafter. In other words, if we don't understand the skin and how it's operating, then we would not know or what's going to follow in terms of hot and cold. So we need to keep that in check all the time. Before we move forward, and we've covered quite a bit in this little segment today, before we move forward, let's give them a break, Looney.
Okay, cool. Mindsetters, we are going to take a very short break. Don't go anywhere because we've got After Earth stuff coming up. So stay tuned, stay glued to your screens, and we'll see you straight after this. Welcome back, Mindsetters. I hope you guys enjoyed that trailer with Will Smith and Jaden kicking the animals, you know, and just being together, trying to fight in order to get back home. I hope you guys enjoyed it. As you can see, I'm all After Earth here, you know. Got my little gadgets going on. So this is the After Earth notebook that you can win. It's in the goodie bag that you can win. It's just so cool, guys. You see, it's got lines so you can write. When Aslam is teaching you life sciences, you know, and you just want to write down the notes, you can write them down here. But the coolest part, guys, of this prize is this awesome pen. No one has ever seen a pen that does this. No one. In this life. Blue light, guys, it just appears. You click it, and blue light appears out of nowhere. After Earth pen, you get to win this as well. You also get to win an After Earth sweatband, you know, when you're jogging there, and then you just need to wipe your sweat. This is quite cool, guys, and it actually has a zip, so if you want to put in some money or your little iPod or whatever you want to put in, you can put it in there. And there's a cool After Earth t-shirt that you can win. So all of these great prizes are in the After Earth goodie bag that you can win. But in order to win, and those 2 tickets, guys, so in order to win, you need to do the following. Go into learnextra.co.za/After Earth and enter in the following code word. Grade 12, sorry. Your code word is revolution. Revolution. That is your code word to remember to enter on learnextra.co.za/After Earth. Stand a chance to win these awesome prizes in that goodie bag and those 2 tickets. Remember, guys, if you don't have a friend, you need a friend, I can be your +1. There's you, then there's me, +1. Remember, guys, you can also enter on learnextra.co.za/After Earth. Don't forget that, okay? To win all these great prizes. I'd just like to congratulate Oleboheng Malapane. I hope I pronounced that right. Oleboheng Malapane, you have won yourself those 2 tickets and these great prizes. They will be coming to you, but remember, guys, I did post on Facebook that you will get an email. So all of those guys who are asking me, I've won a prize and how do I win? How do I get it? How is the tickets going to get to me and all of that? Remember, you will be sent an email and all that information will be given to you. So Aslam, let's do this, man.
You say a lot, eh?
I know I can go on forever.
Tell me something. Did I ever tell you my African name?
You have an African name?
Yes.
What's your African name?
Oleboheng Malapane.
Really?
Yes.
So you won those 2 tickets?
That's me. I won.
Guys.
Oleboheng. That's what they call me when I go back to the village.
In the hood, eh?
Yes,
That's your name.
Another thing, that pen, you did something.
Yes. Check this out.
But I want the pen to write for me. Can that do that for me?
I'm not sure if it can write, hey?
It
just lights up. I haven't been able
it
to
only
work
lights
out
up. All
how
right.
the thing comes
So I
out.
can-
Because
I
it
can-
does have...
So I can write in the dark.
Of course you can.
Okay. And you know what? You shouldn't have told him about that zip.
Why?
Now you've alerted all the criminals. When those guys running with this After Earth one, those are the ones that got money there. You mustn't say all that.
Oh my God.
Those are secrets. You mustn't tell everybody that. Welcome back, guys. I'm hoping you enjoyed your break. There's some nice goodies to win there. Before I start, I've poured some ice cold water, and I'm going to drink some of this water now. Okay, I'm going to drink all of it actually. That's not because I'm thirsty only. That's because I want to show you something. Not how I drink water. Cool. Now, this is not going to happen instantaneously, but we're going to try something. And I'm going to put this back in my mouth. And let's see, Looney.
32.3 degrees Celsius.
Now, I drank some water, and my temperature is showing now 32.3 degrees. Obviously, that's not my whole body temperature. That's because there was cold water probably in my mouth area that's going to make it cooler. But remember, when you're drinking cold water, you are cooling your body. And if you're drinking cold water, etc., after a short while, the body temperature will drop. But the body temperature will kick back to normal in a short while as well. At the same time, if you exercise or if you are in the very hot area, your body temperature would rise, but it would come back to normal after a while. And we're going to check just now if it comes back to normal as well. But remember what I told you, in our case, we do not have all that time to waste 10 minutes just on waiting for the water down and what have you. So we're showing you in a different way. Just to make you understand, I think lots of kids, when we talk about vasodilation, vasoconstriction, they have a problem understanding what is that. First of all, vaso comes from transport, and vaso in our body, the transport is the blood in our body, blood vessels. Now, if we look at a normal cross-section of a blood vessel, let's say this is what a normal cross-section would relieve. This is the lumen. This is the space in which the blood will flow. If we talk about vasoconstriction, notice what happens. It becomes narrower. You cannot say smaller. You cannot say thinner, etc. We're talking about narrower or vaso or constricted. Those are the words we want in the exam. Okay? Rather, you stick to constriction. Stick to constriction. And vasodilation, you see what happens there? There and there, there and there. This is wider. This is narrower. So this is what we need to understand when we're talking about vasodilation and vasoconstriction. So this is what we need to know. Now, let's get to the nitty-gritty. So they say, if the weather becomes too hot, or if your body temperature rises for some reason, weather is hot, it's a hot day out there, etc., or if you are exercising, what happens? First of all, vasodilation takes place. What is this? The blood vessels leading to the skin capillaries become wider, they dilate. Now, how do the blood vessels understand this? What was our question earlier? Our question asked which part of the brain controls it. So we have heat receptors in our body which will sense this rise in temperature. And this message is sent. So from the heat receptors, the message, the impulse is sent to from receptor obviously via neurons then. The message will be sent to the hypothalamus. The hypothalamus also has some heat detecting mechanism, and the hypothalamus then will send messages to the blood vessel. So the brain sends messages to the blood vessels, instructing the blood vessels to become wider or dilate. Can you see that's 2 extra marks there for giving that part? Where did it start, this whole situation? So the blood vessels become wider, they dilate. And what happens when they dilate? Obvious, Luni, allowing more blood to flow to the skin. So if they become wider, then more blood flows to the surface of the skin. And if more blood flows to the surface of the skin, this blood will carry with it heat. And when this heat is brought to the surface, more heat will be lost from the surface. So again, when it's too hot, when the temperatures increase, the receptors pick this up, they send it to the hypothalamus. Hypothalamus instructs the blood vessels to which ones? The capillaries, or the skin capillaries, right? That become wider. And when they become wider, more blood will flow there. And if more blood flows there, more heat will flow there. And if more heat flows there, more heat will be lost. By the way, in grade 4 already, you learned how heat is transferred in 3 or 4 main areas. For example, one is through solids. Heat transfers from solid to solid through conduction. I'm going to write that at the bottom here, and we'll come back to these things just now. Conduction in solids. A perfect example of this would be in the morning when you're having tea. If your tea is very hot and your spoon is in the tea, you'll find that the spoon itself feels hot. And your coffee mug or your tea mug or whatever you're drinking out will also feel hot. What has happened? The heat has been transferred through that solid. So this is conduction. And if we're feeling hot in the studio, we put the aircon on. We don't have an aircon in every corner. We may have an aircon in one area, or in your house at the moment it's getting colder, you'll have a heater. You don't have a heater in every corner of your room. You just have one heater, and this heater will heat the entire room out. And how is this now? Heat is traveling through the air. This is known as convection. And we also have the situation if you're standing outside and you're basking in the sun, you can actually feel the sun's heat. So heat is traveling through space from the sun through space, and you are feeling this. This is known as radiation. And heat can be lost by evaporation also. This is when a liquid changes to a gas. So these are the ways in which heat can be transferred. So let's go back to what we were talking about. There we go. So when we're saying that more heat comes to the skin surface, then more heat will be lost by conduction, convection, or radiation. All of that, okay? At the same time, because more blood is coming to the skin, the sweat glands are also more stimulated. And when they're stimulated, they release more sweat. Now, it's not the releasing of the sweat that cools your body, but it's when that sweat is on the skin surface and it evaporates. Remember, we said one of the heat loss methods was evaporation. So when the sweat evaporates from your body, this has a cooling effect on the body. So that's what's happening there. So the two most important things are these two things that we are talking about. By the way, you can also bring in your endocrine system here and say that less thyroxine is secreted in this time, so the metabolic rate also decreases, and if the metabolic rate decreases, there's less body heat produced in this time. So that's the third angle of this whole thing. Okay? Now let's look at that diagrammatically. And we need to look at this diagram here. So when it is hot, the blood vessels to the skin, can you see these ones? Narrower, these ones wider, dilate, and they're coming closer to the surface, and in that way, heat can be lost from the surface of the skin. And we said that also, as you can see, the president under heavy grilling maybe, is getting heavy questions, and it's very hot, and you can see the sweat trickling all over his face there, and in that time you know you don't have to look at the president, the ex-president of America or wherever else, but you look at yourself when it's hot, what happens to you, okay? Good? Let's move on. Obviously, guys, if we go to the other end, when it's cold, what happens? It's the opposite. So first of all, vasoconstriction takes place. And what is that? The blood vessels to the skin capillaries become narrow. Again, obviously, the message is going to come from the hypothalamus to the blood vessels to instruct them to become narrower, to constrict. And when that happens, less blood flows to the skin and less heat will be lost. So conserving heat. So less heat loss. Obviously, in that time, there's less blood going to the skin, so there'll be less sweating because the sweat glands are less stimulated, less sweating, and therefore, there will be no cooling there. In addition to that, this may also happen. The muscles may contract rapidly, and we start shivering. Oh, it's cold, it's cold. Huh? These contractions need energy from respiration, and therefore, the metabolic rate will go up, and this produces body heat. In addition to this, there can also be more thyroxine released. And this may also increase the metabolic rate. And when the metabolic rate increases, it produces more body heat. And again, back to our diagram. Vasoconstriction, the blood vessels become narrower, and therefore less blood goes to the skin and less heat is lost by the skin. Luni.
All right. Mindset is we're going to take a short break, but after that, I'm going to tell you about winter school and Saturday school. Remember those two things, so we'll see you straight after this break. Welcome back, Mindsetters. Like I said before the break, I want to tell you about Saturday school. From 9 till 1:30 on Saturday, this coming Saturday, guys, we'll be having maths, life sciences, and physical sciences. So at 9 a.m. in the morning, at 9 o'clock in the morning, we'll be having our maths lesson. It will be an hour and a half. So you'll have the teacher, it will be a live broadcast, guys. We'll have the teacher going through some revision questions, and we'll have a presenter talking to you guys on Facebook if you have any problems. Then at 10:30, we'll have our physical sciences lesson until 12, and then from 12 until 1:30, we'll have our life sciences lesson. Grade 12, I do suggest that you guys do tune in. I was presenting last week, and it was such a great show because you guys go over the revision questions that you're actually doing for your exams, so it will help you very, very much. Then we have winter exam school, guys. If you guys don't know about it, you better be knowing. Register yourselves, guys, for winter school. It is from the 1st till the, let me just get my information right. From the 1st to the 5th of July, we have winter school revision. So we'll have that, and then we also have winter exam school, guys. So just make sure you check on Mindset. I will post all the information that you need about this Saturday school and this winter school exam revision, guys. It's a great thing to help you guys for the prelims and for your finals as well, because you need a lot of practice, guys. I was there once and it was no joke, okay? No child's play in matric. So make sure you get all your information on the Facebook page. This is a great textbook to get, guys. It's written Life Sciences for All. It is from Macmillan. Our show is sponsored by Macmillan, but I'll tell you about it when we're ending our show. But now I'll take it straight back to Aslam, or AKA Olowokgang Malapane.
There you
He's got
go.
a thermometer in his mouth again. And the reading this time is 36.9 degrees Celsius.
So we are back to our normal body temperature between 36 and 37 degrees. I want you to keep that in mind, that if it goes down, comes back up. And we're going to do something a little later to see what happens if it goes up, what's going to happen. Okay, so what we spoke about just now, we're just going to look at it in terms of a diagram. All right? They say in cold conditions, this is you can picture yourself in the cold conditions. As we speak right now, you probably have the heater on and so on. First of all, to decrease heat loss, what happens? The constriction of the blood vessels of the skin, we spoke about that. A reduction in sweating, we're not going to sweat in that time. And conscious behavior, now this is not a physiological response. What we're going to talk about, hey, what happened there? Okay, my hands are a little bit static here. We're talking about below that physiological response, above that, sorry, is physiological response. Now here is behavioral response. So you do certain things. For example, you start putting on a jacket, you put on a scarf, you put on a cap, etc. Or you shelter yourself from the wind, or you start rubbing your hands, or you put your hands in your pocket, etc. This is behavior. Fortunately for you, it's not prescribed yourself, but again, if it was, it wouldn't be difficult, right? Because you do these things. And you can also reduce your surface area. Know when you go to sleep and it's cold, the first thing you do is you curl yourself into a little bit smaller. Why? Because less of your body surface area is exposed. And if less surface area is exposed, less heat lost by conduction, convection, and radiation. On the other hand, or rather, still in cold, to increase heat production, you may start shivering. Shivering creates friction. Friction needs respiration. Well, friction creates heat on its own, and shivering itself needs muscles to contract. Muscles to contract needs respiration. Respiration will produce heat. You've done that in grade 11. You also increase voluntary activity. You can walk around a little bit more. You can do certain things. increased metabolic rate. This is a long-term response, which we spoke about earlier about thyroxine. Now what happens when it is hot? In heat, to increase heat loss, you dilate the blood vessels in the skin. So more blood goes to the skin, more heat loss. You're going to secrete more sweat. And then you may start taking some of your clothing off, etc. I mean, not all, but you will take some of your clothing off. You're not going to wear so much clothing. You can even put on a fan, etc. Those are behavioral. And also, you spread your body more wide out because it's larger surface area. And in that way, you can let more heat off by conduction, convection, and radiation. And at the same time, you decrease your voluntary activity. You become a bit slower and lethargic because it is hot now, I can't work, and so on. So your activity becomes decreased, so less metabolism, you're going to produce less heat. And long term, again, your metabolic rate will decrease to a very low level. Good? This one here is just showing you now the same thing, but in a flow diagram here. If there's an increase in body temperature, the thermostat that's found in the hypothalamus activates cooling mechanisms. What are those? Sweat glands secrete more sweat, and the blood vessels in the skin dilate. More heat can be lost by conduction, convection, radiation. Net body temperature decreases back to normal, which is between 36 and 37 degrees Celsius. And if for some reason the body temperature decreases for some reason, same, the thermostat is still in the hypothalamus, and what does it do now? Causes the blood vessels to constrict, reducing heat loss, and there's less sweating at and also more skeletal muscle contraction, shivering generates heat, and this will increase the body temperature back to normal. Notice the cycle. I want you to think about that because we're going to ask you a question a little bit later about that as well. Good. Let's move on. Now we are at my favorite part, and my favorite part is always questions, questions, questions. Luni, have we got any questions on that side that are related to what we are talking about?
Let me check.
You'll tell me if they are, right?
Okay.
Okay, let me carry on with my questions then. Remember, guys, your questions are valuable to us because it's something that you're not understanding, we need to highlight again. I have some of those questions that will take you through testing what we've learned. Can we understand it now, or rather relate to it now? First one is the correct word. Last week we used a little bit of multiple choice and we used a little bit of matching, etc. Now we are looking at one word answers. And guys, this is where you need to know your terminology. When you get a word, write it at the back of your book, explain it in your own words. Also in your textbooks, every single textbook that has been approved that you are using, most of those textbooks, I would say all, not most, all of them have a glossary. So whichever word you're not familiar with, you go to the back to the glossary to see if it is. But then translate it into your own words without losing the essence. Remember, you cannot use slang and common terms where terms are used. You need to use the correct terms. And build that vocabulary all the time. So the first one says maintenance of a constant internal environment. And that would be what we are studying, and that is homeostasis. Homeostasis, homeo, the same stasis, the same state. And in our case, it means maintaining a constant internal environment. And in our bodies, the constant environment is the blood and the tissue fluid. More importantly, the tissue fluid, because the cells are found in the tissue fluid. The cells are not found in the blood. The cells are found in the tissue fluid. Tissue fluid surrounds the cell. So the house, the home of the cell is the tissue fluid. That must be kept constant. Not only in temperature, but also in amount of oxygen, also in amount of carbon dioxide, which you've learned in gaseous exchange last year, also in the form of urea and uric acid and glucose and salts, which you learned in excretion last year in grade 11. So these are the things that must be kept constant all the time, not only temperature. The maintenance of a constant body temperature would obviously be the word we started off, thermoregulation. A type of an animal that I made a mistake there, that controls the body temperature from within, from inside the body. that would be an endothermic organism. It uses energy to maintain its body temperature throughout. Like we were talking about us, the need, we have a need to maintain a constant body temperature. Like us, all other mammals will have the same mechanism, and birds have the same mechanism to keep the body temperature constant throughout. So they use a lot of energy. So endothermic energy, endothermic organisms are very energy consuming organisms. They need to use a lot of energy to maintain that body temperature. Then the next question says the widening of the blood capillaries in the skin. That would be vasodilation. And if we change that to the narrowing of the blood vessels to the skin, that would be vasoconstriction. Method by which most heat is lost through solids, conduction. And if we change that to gases, that would be convection. Condition that occurs when the body becomes overheated. We haven't discussed that yet, but there's a question, and you should know this. If the body becomes overheated, that means above a normal increase in body temperature, if it goes higher than that, that is called hyperthermia. Remember, even when we spoke about endocrine system last week, when we spoke about hyperthyroidism, that would be when the thyroid secretes too much of thyroxine. Hypothyroidism, when it's too little. So the opposite to hyperthermia, the opposite condition would be hypothermia, when the condition when the body becomes too cool, cooler than normal. And we're going to discuss that in a short while, so we'll come to that when we get there. The next question says, study the following diagram and answer the question, and they give you a diagram of the skin. They say label layer B. Notice they're talking of a whole layer B and part C. And that is, that's what you do when you get the wrong answer. So Aslam is a naughty boy, Looney.
What happened?
Got the wrong answer there. He left the wrong answer there. So I'm going to fail the exam. And I'm supposed to teach the whole country.
Yeah,
Ooh.
it's bad.
Can you imagine what people would say about me? Layer B is the epidermis. And part C, the muscle that controls the hair, that is the erector muscle. I'll put it here, erector muscle. Write down the letters of the two parts in a diagram which are involved in insulation of the body. I wouldn't be surprised if this answer also is incorrect, but anyway, let's look at it. I told you, I wouldn't be surprised. All right, sorry about that, but nonetheless, they want to know which are involved in insulation. Insulation would obviously be A and D, the hair and the adipose tissue. So A and D, the hair and... Now, interesting with this question like this also. Notice this one is only asking you for letters. But in an exam, often they ask you write the letters and the name. Please don't forget then, be very careful. You must give both, because in a case like that, there would be 4 marks. 1 for the letter, 1 for the name, 1 for the letter, 1 for the name. So you must make sure that you do that. In this case, it was A and D. And if this one is wrong, Looney, then I'm going to just run away from you. Nonetheless, we will deal with it when we get there. Describe how the human skin maintains the core body temperature on a day when the environmental temperature is around 40 degrees. Now, guys, notice they're not telling you it's hot. They're not telling you it's cold. They're telling you it's above, it's around 40 degrees. By this age, 17, you should know 40 degrees is damn hot. It's a very, very, very hot day. It's not a cold day. It's not cool. It's just not an okay day. It's hot. If in South Africa, generally, we rarely, well, not in South Africa, all over, but in Gauteng, we don't really get to 40. We get to 35, maybe 36 some days. 40, it would be a heat wave. So it's a very hot day then. So you must be able to tell us what happens on a hot day here. And, At least I got one right out of all. So I wouldn't have failed, Luni. I got five marks.
Out of how many?
5, 7, 9. 5 out of 9, that's more than 50%. Not bad. Not for me. It's not good enough for me, but nonetheless, I wouldn't have failed so far. Okay. So, first of all, heat receptors in the skin are stimulated by this high temperature. Impulses are sent to the hypothalamus. We discussed this when we started the section on how the skin is related to this. Impulses from the hypothalamus are then sent to the blood vessels. Vasodilation occurs, or the arterioles to the skin become wider. Try to stick to become dilated or vasodilation. Those are better words to use. If that happens, then more. You mustn't just say blood flows. Blood flows all the time to the capillaries. But in this case, it's more blood flows to the capillaries, and therefore more heat. Heat always reaches the skin surface, but more heat reaches the skin surface now, and more heat is lost to the surroundings. Can you see the repeat of the word more there? And more blood flows to the sweat glands, and sweating increases, and more heat is lost to the evaporation of sweat. So again, we're talking about vasodilation, and we are talking about sweating, the things that are related to the curriculum. Remember, we're not talking about all the hair is lying flat and so on here. The answer is restricted to that part there. The next question there, explain how the skin is suited for thermoregulation. Remember earlier, we spoke about the structure and the functions of the skin. Now we want to know, how is that structure that we spoke about related to those functions that we spoke about in terms of thermoregulation? Not just anything, but in thermoregulation. Not its protective function, not all its other functions, but in terms of thermoregulation. How is it suited? And what do we do there? All right. Here we go. Let me just extend that page. Good. So first of all, I said earlier, remember we said in the diagram they have different nerve endings, different receptors. So in that, we're giving the first one there, the skin has receptors. Remember when you're talking about structural suitability, what does it have? It has receptors. For what does it have it? To detect temperature changes. So structure, function. We are marrying the structure to the function. It has the receptors. Why? So that it can detect any temperature changes that happen. Further, it has what? It has sweat glands. Why? Because they secrete sweat. Why? The evaporation of sweat causes cooling on a hot day. Again, structure, function. Marry the two together, you get suitability. Skin has a layer of adipose tissue which acts as an insulator. And skin has hair which traps air and can act as an insulator. So these are the structural suitabilities of the skin in terms of thermoregulation. Anything on our side, Luni?
Yes, we have a question from Henny Mulaudzi Jr. the second. This question
comes from the royal family.
Apparently,
yeah.
This question just
Henry,
came. Yeah? Please. This question just came to my mind now. I'm curious about how thick is the skin from the level of the adipose tissue to the horny layer.
Oh.
And then he continues, because I commented, and then he continues to saying he was curious to know what would happen if you cut yourself accidentally, like how much would it measure?
If you cut yourself?
Yes.
Okay. If you cut yourself, remember there are blood capillaries on the surface of the skin. So already it's dangerous. You shouldn't be cutting yourself. That's the first thing. Oh, by the way, you know when we did the headstand long time, Luna, you were here when I did
was here, yes.
I forgot to tell you, and I'm going to tell you this to protect myself and mindset. Please do not try that alone at home.
Don't
we
try
should
it.
say that before we do anything funny on the show. All right. So again, do not cut yourself. That's not a good thing to do. Okay. But obviously, by the time you know by now, if you have slight paper cut, Luni, you start bleeding. There's blood capillaries right on the surface. So the skin surface is not that thick. It's not that thick. One just has to simply lift up there to feel when you're feeling the bone. It's not that thick. It's, I would say, a few millimeters at most. And remember, when we're talking about it, the epidermis is very thin in terms, well, thick in terms of a membrane, but thin in terms of, an orange skin, the skin of an orange that we eat. It will be much thinner than the skin of an orange. Okay? I'm hoping that answers Henry's question. I'm not sure where what he actually wants there. Any other questions?
Okay, we've got something from Sfundo Sitole.
Yeah.
I'm not sure what he's trying to ask, but he says, guys, what about, is it Lamarck,
yeah.
Lamarck and Darwin?
Lamarck and Darwin are on evolution, young men. We're not discussing that now. That will take us the rest of the show, and we cannot go there now. Okay. If you want to, go to our previous show. I mean, we looked at that on Saturday as well. So go to Saturday, click on the video, and watch that. It does Lamarck and Darwin in the questions and previous shows as well. Good. Let's move on then to our questions, or rather our comments first. What can go wrong? First of all, we said earlier, if your temperature goes too high, then you're suffering from hyperthermia. This is an increase in the temperature above the normal, that means more than 37.5 degrees, due to the failure of thermoregulation. That means it's very hot out there, your temperature is going up, but your body temperature is not correcting itself, and the body temperature is not coming down, according to what we said earlier, that you sweat more and so on. That means despite these things happening, your temperature is just going up all the time, and that's not a good thing. So what causes it? First of all, extremely high temperatures. You're in an area where there's very high temperatures, and they cause an increase in sweating. Now, while you're sweating, what happens is you dehydrate. That means you're losing your water. And if you don't have water in your body, then you can't sweat after that. So now the sweating stops. It's so hot that your sweating has even stopped, and because of that, the temperature starts rising. And at the same time, while you're doing that, you're not drinking sufficient water when it's hot also. And during prolonged exercise, if you are exercising for a long period of time and you're not drinking enough water, this can all these things can cause that. Right? So this can lead to a further increase in the body temperature. And what can go wrong? You can get a heat stroke. The temperature is above 41.1 degrees. This can lead to coma, seizures, confusion, and no sweating because you have lost the water already, dehydration. Symptoms are obvious: increased body temperature, hot, dry skin, increased heartbeat, an increased or a decreased blood pressure, headache, confusion, and it can lead to unconsciousness. And if it's not corrected, it obviously can lead to death. What can you do? Move the person to a cool, shady place. Cool the person by covering them with damp sheets or spraying them with water, not with a big hose fire hydrant now, in a little bottle, and you spray them a little bit with water. Cool the person with a fan, keep person hydrated, and get medical help for them. And if they are suffering from hypothermia, if the body temperature below 35 degrees, mild 32.32 to 35, moderate 28 to 32, severe below 28 degrees. Causes extreme cold, taking sedatives and alcohol when it's cold, not a good thing because it causes sweating, and that's not a good thing. Certain medical conditions such as heat problems, etc. The symptoms: violent shivering, which stops as hypothermia becomes more severe, and all these things: confusion, difficulty in movement, memory loss, tiredness, slurred speech, etc. Treatment: move the person somewhere warm, change them out of the wet clothing, because wet clothing decreasing the insulation. If you have lots of clothing and they wet, they decrease the insulation of that by 50 to 60%. Wrap them in warm clothing, give them warm drinks, but not alcohol, because alcohol dilates the blood capillaries. Luni.
All right, Mindsetters, remember Korea Indaba is at the Centrum Convention Center from the 20th till the 22nd of June. We will be there, so come say hi and all of that stuff, guys. You'll get great information about the career path you want to take. Life Sciences was proudly brought to you by Macmillan, guys. Remember, Saturday school, your lesson is at 12. So come join us, guys, and we'll see you. Paper 2 revision, so we'll see you then. Bye!
Ooh, you're becoming an opera.